Let's go through LeetCode 386, lexicographical numbers. And this question, it gives us an integer n, and let's return the lexicographical order from 1 to n. And for example, to give n equals 13. So the 1 is the smallest, and 1 0, that is from lexicographical order, that is the second one, because it starts as 1, right? And then 1 1, and 1 2, 1 3. Then 2 is greater than 1. So this has those kind of orders. So intuitively, we're thinking about possibly we convert those numbers to string, and then sort by string, and then convert back. But for this kind of range, maybe it will pass that. Maybe it will pass. Maybe it will be time auto time time. So because sort it will have n log n time complexity. So for this question, we need to have some other solutions. So let's try to observe those kind of the numbers. For example, we want to we want to have the result is that, for example, we have n, right? That will be 1 2 3 4 5 6 7 8 9, and if we have 10, right? So we can put the 10 as the 1's child, and also it have a child 11, 12, and until 19. And for the 1 0 0 1 0, it have a child 100, and 100 and 1, and until 100 0 and 9. And for 11, we can have a child like 110 to 119, right? So if we compose, for example, like a tree, right? We can also have a 0 as a root. But for this one, because 0 is not included, so we can have like a trees. So we are observe that kind of rules, trying to find what we want to get a result is that this will be lexical smallest, and this is the second, and this is the third. And let's take an example. For example, this 13, right? For example, we want to have smaller than 109. Okay. So we'll see. It will we go like this way, and then like this way, and this way. Then it go back to 1 0, go to 111, right? And then we try to go to its child again, find that this greater than 1 0. So we just trim this kind of trees, then go back and trying to go to its child and go back. So until we to 119, right? So if we traverse like this kind of order, we'll find the result. It will be something like 1, 110, 100, and 101. And this is what we want. Actually, those kind of order is just trees pre-order traversal, right? So we can just use trees pre-order traversal to do these kind of questions. So right, we can write so let's write code for this. For this kind of solution, because every number we just traverse one time, so it will be O n time complexity. So we say the 0 is not included. So we are going to have let's have this result first. And we're going to have for int I equals 1, I smaller than 9, I plus plus. And for each tree, each number, we're going to have the pre-order traversal. So that is a DFS. We are going to have a have a integer I, and also we're going to have those kind of results, and we just return result. And among we know this tree that those kind of parents to its child, right? For example, this is I, and its child will be I multiplied by 0 plus 0 until I multiply by 10. I multiply by 10 plus 0 to I multiply by 10 plus 9, right? There are 10 combinations. So let's write the DFS function private void DFS. We are going to have int current number, right? And also this integer as a result. The exit condition for this DFS is that if this parent already greater than, we need to have n, right? Greater than n, have a limit bound int n. Okay. If this is already greater than n, then we just return. And we know this is a pre-order, so we need to have the result at this current first. And then for then we iterate this number as child, that is for int I equals 0. Now 0 should be included because for its child, it just have, for example, this is 1, right? I have 1 0, 1 1 to 1 9, right? So so we have I equals 0, I equal to 9, I plus plus. And now we're going to have DFS current multiplied by 10 plus I and result. So this will be the solution. 13 2. Sorry, this should is smaller equal to 9. So this will be the O n time complexity.